Welcome to a Saturday. I didn't was online last weekend. I was going to be, but I had problems with the computer over there. Um, I had real big issues getting the camera started after an update, and I got, as you know, there's four cameras here. One of them wouldn't work, the other three would. And I get that one working, and then one of the others wouldn't work, and it was constant. And then when I was fiddling around. I think, okay, well, maybe it's the USB buses, hubs, whatever you wish to call them, um, conflicting again, right? So normally I have the top cam on one bus. I have the other three cameras on three different other buses, right? The other three cameras aren't USB 3 cameras, they're just USB 2.0 cameras. So I can plug them in, and I have technically four, or is it five USB hubs in here, buses. So I had a USB-C that I wasn't using, so I tried it. Nope, they couldn't get it to work. I fiddled and fiddled. I end up actually to one way to solve part of this problem is in the future, even though I have it technically running, it's I think iffy. I'm going to change the motherboard in this system so that it has more PCIe slots spaced farther apart. And then I'll have my video card, my capture card, and another PCIe 3.0, 3.1 rated card. So in there. So that'll give me another spot to hook something up to. Also, I'm going to change this particular Moki 4K camera out. I've already ordered another one that actually has HDMI and USB 3 on it. So I can send it to the capture card. Or I can send it from its USB 3 to the new USB card. I'm not 100% sure I'm going to do it yet, right? Um, but I got everything working. And it turned out one of the biggest problems was actually OBS. I had to move the whole OBS setup directory out of the way and let OBS create a brand new one. And then I had to put all the cameras back in, recreate all the scenes, do the audio, all the usual stuff. And surprisingly, one of the things that started happening, which I didn't have working before, is this top camera is actually doing 4K now correctly. Before it would do 4K 3 frames per second type idea, and it was just useless. So I usually was running the camera at 2160 by like 1500 or so. It's one of the modes you can do. And now I actually have it on the 3160 by 3180 by 3280, 3480 by 2160, and it's actually running correctly. And as you can see, good frame rate. Of course, this camera is not a 60 frames per second 4K camera. I went looking for something like that. Holy moly, did the price jump just to get a camera like that. Um, yeah, even replacing this camera with an HDMI capable output camera. Wow, that wasn't cheap either. So hopefully, for the moment, I'm good for that. Um, Someone mentioned in a thing that they were trying to get some debugging of Atmel boards working within Visual Studio Code and PlatformIO. So I went rooting around and I found all my programmers and programming kits. So I thought at first I didn't have an Atmel programmer. I knew I had, for example, this guy here, which is a ST-Link V2, generic one you get off AliExpress. And I've used this before and it works fine. And then I realized I also have the Sager Mini. That's what this is, this little guy here. And this is a little conversion board. So it takes this and converts to two more bigger connectors. This is more the JTAG connector, and this is more the other one, right? So I had that one. And I forgot about this one. I have this one, which is the ST-Link V3 Mini. It's like an upgraded version of the gold one there, a brass one. Um, this guy here, This is, I just got, and this is a one for doing ESP32s. It's actually a ESP32 programmer, debugger. And then I do have this guy here, which I haven't tried much. This is like the Flirk, or I think they call it the Black Magic Probe or something like that. But it's an open source one. It's supposed to work pretty good. So that one. This little guy here specifically to program AT-Tinies. Now, I don't know if this little guy here can do anything else. I don't think so. I think it's strictly to program AT-Tinies. I did have from Adafruit this item, which is a breakout for this tiny fine cable. So that if you don't have the connector, but you want to use that debugger that has this, for example, the Sager, you could put it on a breadboard and then jumper wire from there to the other board. Or, male to female DuPonts, right? And then I remembered I have the, where is that? Here, let me just find it for you. I have this. This is my retro chip tester. And in order to program the, under here, it's sitting under here, through here, the Atmega chip on here, it's actually the same one as an Arduino Mega. You need some programmer for Atmel. And then I realized I have them. So this here, these guys, are what's called a USB ASP. It's a programmer for Atmel. And if you're wondering why I have 3 of them, I bought one of them, and then I found out I had to actually do a firmware upgrade, so I bought a pair of them, and that was just the deal of the day. And that included on the other ones, which I think the first one I bought didn't have it, but these two did. They had the little converter board that converts this to the little guy here. And this, you plug into this, like so. And then you can program this. So I used this to program all the other ones. And then once I had the other 2 programs updated, I used it and reversed it and programmed this one. So all 3 were updated in their programming. It's actually a project from some guy, although the cloners in AliExpress land, right? They cloned the boards. But I got it all working. And then I have some newer style programmers, but they're specifically for these guys. These guys are those CHV32 whatever model number chips. This particular one, I believe, is the 307 EVT. And it turns out these particular CH chips have 3 or 4 programmers that they can use, depending on what the board is and what you're doing with it. Now, I had that little sample board of the CHV 32003. It was the same one that Dave on EE blog was talking about. It's like under a 10-cent chip. But it's supposed to use a one-wire programming system, but apparently this particular programmer that came with this particular board, which I got, which happens to be the WCH Link R1 1V1, didn't work with it. So I ordered some alternate. I actually ordered 2 different types of things for them. This guy here, which came in. Whoops. I think I just dropped something on the floor. Give me a sec. Felt like I dropped something on the floor. Oh, maybe not. Okay. So this was a kit. There are two parts to this order from the same company. Okay. Oh, I might need that back. This guy here is the other demonstration board. It is also a CH, but it is a... Oh, it's also a 307, but it's a slightly different board. I didn't have to do any of the pinnings on it. And it comes here, this guy right here, if my understanding is correctly, is the same as the programmer. But this one's called a R1 1V0. And then, of course, they gave me a little strip of 5 chips for who knows what I'll do with, right? And then this other part of the kit was, this is the same 0003 one, slightly different board, but this was, apparently this is the correct programmer for it. And this one here is the WCH Link E R01V2. And this apparently is for programming the 003s. Whereas this programmer does these guys. But in this particular case, you don't need it because this has effectively this on here. You can kind of see this chip and this chip, you can see. So in fact, this is a lot like the ST32 Nucleo boards, the kits. They have a programmer on one part and the main board on another. But you can see basically this board is practically identical. It's kind of weird though. I mean, this board, I had to solder all the stuff on it, and all they gave me is male pins. But on this one, they gave male and female pre-soldered on already, and little legs on it, of course. Right? Now, in this guy here, is one more programmer for these guys. And this happens to be... So we have the, as I said, we have the R1 1V1 WCHE or whatever. And this guy here is the 1V3. It could be just a newer one, but it's kind of weird. There's, ooh, they bent it. Oh, guys, how did you do that? Let's see if I can get the shell apart. That's not good. I didn't notice this. I haven't opened this up yet, so... I need a more pokey thing. There we go. There we go. There we go. So this got bent. It's not good. So the funky thing is, this one doesn't have buttons on it, but these two both have buttons on it. So I think this shell is kind of dumb for this one because this guy's got buttons on it that might be needed. IAP mode switch, right? So I'll probably leave the stupid shell off. It's not worth keeping it on there. And so this one, as I said, is RO1V3, Link E. This is RO1V2. I mean, it could be just two versions of the same one, but definitely this one's a different one. It's ranged differently. It's done differently. So now that's not all the programmers we have. I'm just going to put these programmers in this bag. So those are all the CH programmers, and I think I have coming one more. And I think I got all my bases covered for those. The other one, of course, is the Raspberry Pi's programmer debugger, which is this guy right here. And this kit comes with cables and stuff in it, and little pinny thingies on the JST connectors, and a nice red Raspberry Pi cable. But I do have all of them. Now the trick is, I was already reading up on how to set some of this stuff up. I think I might start actually with, because the instructions are pretty clear on Raspberry Pi how to do the Pi one. So, and I think I had them all in a bin here, up here, miscellaneous parts, programmers. These are more than just programmers in here. There's some other conversion jobs like serial TTLs and stuff like that. So, but all these guys are going to go back in here where they belong. Now that I collect them all up, they can all be in the same spot. And I'll leave the one Raspberry Pi out. And of course, this guy here is going to stay together with this board. And this board can go in here. And these guys can go in here. Now, it's going to have some more stuff to look at, but I think the DHL airplane from New York for Adafruit got lost and went south from Albuquerque or something like that, because they were over a day late getting to Cincinnati. So something must have happened. Yeah, I don't even know what to do with these little chips. That's tips. Oh well, I'll just shove it up into the collection up there. You can never have enough loose bards and stuff on your monitor stand. So, okay. So that's where I stand on the programmer. So I'll get more work done on it in a bit. Someone else had a comment. Let me find it again. Yeah, so I think he's got a misconception in code. When you look at my plugins that are actually installed here, right? This plugin here does all the CircuitPython. PlatformIO is not involved in it at all. It's one that handles all the stubs, everything, updates itself based off the current community library and stuff like that for the CircuitPython. This guy here, this plugin, this is the C code, C++ code of Expressive's IDF. It's their plugin in Visual Studio Code to run this system. Now, I haven't done much the C programming except a few demos on LED blinking on it. And then, of course, this guy here, this one's more Arduino I use for doing that. Plus, it has control. In Arduino, it has a ton of boards. We're talking. This guy here is worth. I don't know, 1,200 motherboard. Sorry, 1,200 controllers or so. Now you can see up here it says ESP free toss libopen blah blah blah. In it there's 3 frameworks. I think if I click on here, and it's going to do an update to PlatformIO, of course, because we've had an update in a while. Now I'm going to, in this particular, I've done this on my VM, but haven't done it on this one yet. I'm going to add the CHV32 framework to PlatformIO. Yeah, we'll reload. So now when we go to the hut, and what we're after here is platforms. So we have Atmel platforms, Expressive platforms, Raspberry Pi platform, STM32 platform. We're going to end up adding another platform in here. I have to find the instructions again because I did it over there. But basically, you point this thing, you add another platform, you point it to a GitHub repo, and it puts it all in place. And now, then you can pick that one. And that means you can do the CH32V, CHV32V framework. And voila. Okay. Just a sec. Okay, I'm back. Sorry about that. So yeah, where did I leave off? Oh yeah, putting the CH stuff into PlatformIO. I think I could actually dig up the docs. It was fairly easy last time. CH32V PlatformIO. Installation. Let's see. What do we have to do? Oh, we need some UDEV rules. So let's go over to this. UDEV rules. Fine 99 platform IO. UDEV rule. Oh, look, the Sega G-Link is in there. Okay, so for Linux platform, group plug dev. Why would I want group plug dev? I never figured that one out. Well, open CH 32VXX chip. Go get the rules. Like so. Why do I have to specify subsystem USB? We already know it's USB. I think I'm going to change these slightly because you really don't need it this way. You can do this. And then on the end of here, not plug dev, just do this. Mode equals quotes 0666 close the quotes. And we can make it more like the other ones. So we'll add in comma. Oops, my mode is wrong. Here, just a sec. MODE. There we go. Comma, and we'll add in this component right here. Like those. We'll make the lines more like what PlatformIO is using. So we need this whole line now. Like so. Like so. That should do the trick. Attributed vendor, blah blah blah, blah 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 blah. Okay. Shift Z Z. Then you need udev admin trigger and control R udev control R. That's better. Okay. Without these udev rules or the missing group membership of the user in the plug dev group, I don't even think I have a plug dev group, you know. Less etc groups group. Oh, I do have a plug dev group. What do you know? Okay, we'll just tweak this slightly more. Append, comma. We'll put the group in. Doesn't hurt it. Doesn't do anything. And plug dev like so. If you're wondering how I did the repeat like that, that's just Vim and the dot. It repeats the last thing you typed before you went back into control mode. There we go. Okay, so how do you install it? I got those parts. I just need the line that they were using before for adding it. CHV32. Nope, that's not what I want. Development version. Do I just point it at the Git? I cannot remember. I did this a while back. Okay, no. Read me. Da, 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 da. Oh, there it is. There's the one I was looking for. Installing it. Assume that you have VS Code Plus, Platform, blah, blah, blah. We have all that installed. Okay, so we need that guy, and we are in Platforms. Platforms, and we want installed at the top, advanced installation. Then we need the Git line right here, like so. So this will take a moment of time while it puts it all in. I better be careful. If I sing the right tune, YouTube will complain. Your copyright violation. Yes, right. Okay. Successfully installed. There it is, right there. WCH CH32V. Now a platform install. Okay, importing examples. So we need our command prompt for a sec. CD work. Where shall we put this? Well, we could put it here. Like so. Okay. So back to this. Home. And we want to open project. Yeah, so we're going to open a project. We're going to bound to projects into here. And we want Blinky non-OS open. A Git repository is found in the parent folders of the workspace for OpenFile. Would you like to open the repository? No, not really. Okay. Let's go to source, main C. There's our code. And oh, one thing I have to do, I have to turn off the ESP IDF because the buttons down here, there's too many of them. Just give me a sec here. Expressive. We'll just disable it for the moment. And I'm just going to come back into Visual Studio Code again. There we go. Oh, what the heck, we'll just... Okay, so now our button's down here. And we go over to main.c and we bring this window a little farther up to see what's going on. Yeah, it compiled. There we go. So the only thing I have to learn on this is how to actually send it to the chip itself. And probably, I think on that chip, that little green board, or even the little other one I have, just a sec, I'll go get it. It's over on the other table. This guy right here. So I should really pin this thing so they can put it on a breadboard, and then put the programming pin thingies over there. So this is the ground voltage and the 1-pin programming wire on here. Couple of those, and then we want a right angle one, or do we want a vertical one? Well, let's see. Then you need one like this. Yes, I'll solder it. Don't worry. And then on the since we only need 3 pins, like so. And then we put these 3 here like so. Oh yeah, did I go through that? Well, let's do that too. Side note, feeding and maintaining your soldering pencil. When you buy a pencil, it's always a good idea to buy spare parts for your pencil. So this happened just a couple of weeks ago. This end here, this piece here that's in here died. So this is simply a heating element for this style of a pencil. Now, this style of pencil, there's your heating element in here. So this is your end style. This is really a Heiko knockoff end. So there is another style of end you can get in pencils where this is a big long bar like this. It's all built into one and it slides in. This is the style where you have this heating element. You put this like so, and you put this on so. And then in here, okay, and if you push, so this is the board that transfers the 4 wires from the soldering station to the 4 wires in the heating element. So what you have here is 2 clear wires, usually a red and blue wire like this. And the clear wires are the heating element. The blue and red wires are basically the sensor, the thermal sensor. And then there's 1/5 wire. That's the ground here. That's the grounding thing. And then you slide it into this thing in the right way, which I just have not done. It goes in a certain way. There's a little notch in here that you have to line up so the circuit board slides in correctly. It is right there, like so. Okay. And then you would put this through here like so. This is all off, by the way. Don't do this on. That's a bad thing. Tighten it up. You put your tip back on. Now, of course, catch 22, you need another soldering pencil to fix a soldering pencil. I keep my old Aero IO, AOYOR, something like that. So we just want to make sure that this is like that. So that makes it nice and smooth. So I could tell this wasn't working because on the soldering station, the temperature wasn't rising. So my soldering station has a temperature on it. Not only the temperature you're targeting, but as it climbs up to that temperature, you can see it incrementing. I do know another thing about this. Watch out that you don't run the pencil too hot. There's no need to run it at 400 degrees Celsius to solder. Also, you'll keep spare parts like that I do in this little bin. So this guy here, for example, this is the spare heating element for the air gun component of the station. So it is a rework station, so it has both. Okay. The solder that actually came with this, I never use it. Spare tips. Cleaning parts for the desoldering station. But down in here we have spare brand new and a used one of the heating elements. Actually, I have another one down here. I have made several. I have 4 of them. There's another one. And another one. Right? All these guys. In fact, they probably were in here at the one time. This is rosin. This is a trick I learned from one of the YouTubes. Just get a little bottle with the needle top like this. Put that stuff in it. So you have a flux dispenser. Tweezers, of course. More solder that came with another kit. Spare one of these. I got a bigger one. See? This was from another desoldering gun. I don't think it's for this one. I think this one uses a different system. Again, more solder that comes with these things. Also, I have a tinning pot. This is just tin. It keeps your tip nice and clean. So you can see on this tip it's nice and smooth, and of course more solder. Now I have these tweezers in here, but I actually have a different tweezer kit that I use all the time, which is this one. This is like, I think, one of my best investments. Just watch out. They are very pointy and you can poke a hole in your finger really easily with them. But you keep. I also have another bin with more spare parts for from the other pencil. But you keep these around all the time for just in case you have to do what I had to do. I think this tip lasted me this heating element a year and a half, maybe 2 years. So now, what did I do with that? Oh, here's one. We're going to play the soldering game for this. We need to stick it into something. There we go. Also, I picked up this, just a laboratory-based style water dispensing bottle. It's for the sole purpose of doing this. As Dave would do on Eevee, ooh, sponge explosion. Ooh. There you go. Like so. And then the tinning pot is great also for just testing that your tip is good. See? Nice and shiny. Just the way you want it. Oh, let's put the pencil back over here so it's not in our way. I also did one other thing to the soldering pencil. When I very first got it, this cord was the more stiffer, thicker cord. Slightly thicker, but really stiff. I went and got some of that really flexible type of cord that's on the Weller pencils. Um, that really nice, flexible silicone rubber type pencil. And I redid the thread, wired it. So I figured out the pin pattern for the pencil on the old one, wired it correctly. You just have to know how many wires is in your pencil tip. In this case, as I said, 5 wires, 4 for the pencil, 1 for the ground. So I'm just going to solder this on because I feel like doing some soldering. And I'm sorry if my head gets in the way. I have to see what I'm doing. One row done. I do have a thinner solder that I can use sometimes when I need to, but you consume a lot of it when you're doing this. Almost there. Yeah, it's nice. I just don't understand why some of the newest um, boards for programmers and some of the other stuff that are not Adafruit don't go to USB-C. Instead, they're stuck in the old USB 2 connectors. USB-C C is so much more fun. Now I had one more pinny thing here. So we're going to put in the programmer pins here. A little bit too much solder on here. There we go. One set of programming pins. Now, last time I tried this, I didn't have the right program, and I think I have to figure out which one I have to actually correctly use, and I don't know which one. So that'll be another project for this thing. I suppose, I don't know if you can actually do debugging through that at all at this. I have one other one of these things in this size, and then I have that green one that's the bigger one. What the heck is this? Oh, right, I forgot about this. This is the Adafruit Bluetooth sniffer. Keep wanting to look at that. I'm surprised how little I actually program Arduinos and Nanas anymore. But so that's my next step, is to learn how to do the programmers and get that working. And hopefully my Adafruit care package arrives next week. Then I'll have something for the long weekend. What time is it? Oh, it's 51 minutes and 29 seconds. So hopefully this video works out correctly. It looks like so far everything is working. The camera's working, blah, 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 blah. So next step was when the parts come in, I will upgrade the system a bit. I also have a 3600X over there versus a 3600, which is in here, which give me a little more speed. I'm not even sure if I want to bother with that, but I can do that. I think the cooler on here will handle it. So we'll find out. But in the meantime, I'll let you go. I think I'm going to go back into Diablo 4 because it is the great Diablo 4 Slam weekend. Although I did encounter a problem with it. I town portal out of a dungeon and the whole thing reset. So I'm not sure if that was the way it was supposed to happen. I have to test that out again. Okay, I'll let you go.